Good morning, everyone, and thank you to the team here for hosting us. This is very exciting, and I think congratulations to the Openstack community for kind of kicking off this event in Turkey. It's very exciting. I'm going to talk a little bit about views on cloud computing and a little bit of a perspective from Open Contrail and Juniper Networks, but I'd like to talk a little bit about the trends. I think what we've heard so far really tees this up nicely in that users are expecting instant gratification. Mobile users are now dominating the way that applications are consumed, and application developers are having to move faster and faster. That is obviously changing the way that infrastructure is built and delivered. And Openstack being now the fastest growing open source project in the industry, it's a testament to the type of accessibility that people want to new ways of doing things. We spent a lot of time on sort of the definition of cloud, and this is just one definition that was done by the National Institute of Standards and Technology. We've had obviously a lot of evolution since this was defined, but fundamentally it's more than just a technology. Cloud really has changed a lot of business models. The users have a high expectation now about instant gratification, access to services like compute, storage, and networking, and they want to pay just for what they use. So traditionally, as many of you know, infrastructure was built for peak loads. And now people can consume it by the hour and be much more flexible in terms of how they consume those types of services. And now, as we've seen a lot of the shift in value from hardware systems to software systems, the next evolution, as Jonathan teed up, is how do we deliver all these services? So cloud computing is still now one of the main areas of technology spending in 2015 and will continue to be. There are some other things that obviously are being invested quite a bit in the Openstack community around how do we do this in a secure way? How do we make sure things like identity and authentication and encrypted networks and new models of security are built into the infrastructure that we deliver? And then how do we leverage concepts around big data? So when we deliver this type of infrastructure, the operators can actually manage it. And I think that that's one of the things that you'll see in terms of big data for infrastructure and the way that people are doing monitoring and analytics and that feedback loop to the next generation infrastructure. There is a lot of investment going on there. Specifically in the networking world, network management was not necessarily always the best part of network delivery. A lot of folks wrote their own tools. Now, as we're moving this to very distributed systems, the ability for a controller-based architecture and things like SDN to kind of automate at the system level is obviously an area of a lot of investment and I think a lot of innovation. A lot of these lessons are being learned out of things that maybe we have already seen in mobility. And as I mentioned, probably in 2008, according to the latest internet report, 12% of adults who access digital media did it through their mobile device. And now this year, that number is around 52%. So that's phenomenal growth in just 7 years in terms of how people are consuming the applications and the content. And at the same time, the content that is being generated is being primarily user-generated at the edge of the network. So whereas before there was a lot of content that was in very large core data centers, and was pushed out to end users at the edges. Now if you look at things like Twitch and the way that gaming providers and social media and photo and video producers are doing it, a lot of that is initially generated on the mobile device. So if you look at something like Twitch, which was acquired by Amazon, they're doing essentially 100 million monthly active users. That's 122% growth year on year. This is obviously changing a lot of the way that they're needing to build their infrastructure. They've written their own overlay controller. They named it Usher. That does a lot of the optimization in terms of how is load balancing done, how does the video broadcast determine the path that it takes so that essentially live streams are most efficiently delivered. A lot of innovation done by a very small team of engineers who built a highly automated system. This is a quote from the founder of Box, obviously also another large collaboration software company. Aaron Levy made the quote here. It's, enterprises are really thinking not just about how they consume software, which traditionally was very tightly packaged, but more now how software changes fundamentally the way that they work and work itself. If you look at platforms like Slack, and the way that it's replacing email for next generation application development teams. This is now a huge convergence of the way that content, messaging, email, storage, et cetera, is done. And from a networking perspective, our job as networking folks is to interconnect data And where that data sits and the expectation about how quickly that data is being delivered and the things that it interconnects, not just desktops and servers, but now mobile devices and sensor networks, which are all IP connected, is quite different in just a very short period of time. Jonathan talked about not only the success of Openstack as a platform in terms of infrastructure delivery and some of the services on top, but with the emergence of things like Kubernetes and Docker containers, now people are talking about a higher level of abstraction around how these services are delivered. So in the case of Kubernetes, which as many of you know was open sourced by Google to do cluster management of containers, a lot of that is sort of exposed in terms of pods, which are clusters of containers or sets of containers, and services, which are essentially used and tagged with labels so they can very efficiently deliver those services to the containers no matter where they sit in a data center or across a hybrid cloud environment. And with that comes, because we're now building much more distributed architectures, a new set of tools and automation environments and things like continuous integration and continuous delivery models, which are very much changing the entire industry from both the user as well as the operator administrator and the developers. This is just an example for a gaming and entertainment company. The way that they're building their applications is obviously not a packaged application that you buy shrink-wrapped. It's primarily a set of open source application components that are assembled and run in containers, generally, on open compute platforms, commodity x86 Linux servers. The cost of those Linux servers obviously has come down thanks to the scale of the web scale players like Google, Amazon, and Facebook, who essentially buy commodity hardware. They all buy the same thing, and on top of that, they innovate in software. Now, on top of that, this model for how we do X as a service delivery in a way that's very self-service and automated is the next frontier. And there's a lot of innovation going on in just the last few months in terms of how people are thinking about using policy and automation to deliver those services to sets of application components. From a networking perspective, our business has seen a fundamental change as well. If you look at the way that Google and Facebook are building their network environments, it's very different from the way that traditional enterprises had built out their data centers. Folks like Facebook have built out their data centers more like the internet was built, which is essentially very flat any-to-any connectivity with a very layer 3 centric model. And that allows them to essentially take things like application containers and ensure that they can be portable within any cluster, within any data center, anywhere that they might run that workload. They've also essentially not reinvented the wheel, and there's sort of a desire to essentially quickly enable these workloads without reinventing every aspect of technology. In this particular case, the way that the network control plane works is literally the same protocol that is used outside of the data center environment. So pulling some of those constructs in so we can elastically scale in a horizontal way and still communicate directly with the large-scale internet networks that are out there was part of the reason they were able to grow so quickly. Part of the problem at the service layer is that we have still silos and data models that are not necessarily converged. So you still have the problem in some cases of a vendor-specific way of describing a service. Obviously, that's not a problem in something like the Openstack model, where services are exposed in a very vendor-agnostic way through clean and well-behaved APIs. But I think we have a journey here as a lot of this consolidation happens, because as Jonathan mentioned, every customer now expects that whether they run their workload in a public or a private cloud environment, it just works. From a network perspective, we should ensure that we're making a lot of that invisible. It should become more of the utility model in terms of connectivity, but in terms of how those services are delivered, there's still a lot of work to do in terms of how do we do that in a user-centric way where we retain the context of the application and the user environment, and we make sure we do it securely and in a way that obviously scales and is resilient. That bar is obviously a very high bar for the types of customers that are deploying these solutions, the tier 1 carriers, the large emerging web companies, as well as very large enterprises. So we've looked at this model of, how do we take the existing physical infrastructure that's already there, make sure we're not reinventing the wheel on how we do fundamental infrastructure, but focus on this next layer, where we are picking up higher levels of automation, not just for the network, but the control plane and the automation that is done in the network, essentially in a way that communicates with the applications and services on top. Exposing northbound REST APIs as an example from the network was not traditionally the way that network services were delivered. In the case of OpenContrail, which is an open source network virtualization SDN controller model, we have exposed the network system through the Neutron APIs in Openstack. And a lot of the testing that's done when we go into a customer scenario is very much around how does it scale, can we ensure that we have security and resiliency for each component of the environment. But the ability to create this notion of a virtual network that is relevant at the application level. So in this case, the web tier is a virtual network. Containers in the web tier may sit anywhere in the data center or across cloud environments, but the policy is still attached to the containers in that workload. And then on top, the analytics and the orchestration that's done through northbound systems obviously doesn't have to discriminate based on the vendor implementation. So this higher level of abstraction is very, very different from the way networking was done before, where a lot of the vendors did very vendor-specific CLI device-level commands to instrument and configure network environments. This abstraction, if you think about how do you model policy for virtual networks, how do you allocate a floating IP address to the private IPs that are in the data center, how do you make sure you apply services and do service chaining, all of those policies are defined in a way that is very agnostic to the vendor implementation. The Contrail team had co-authored the group-based policy work within OpenStack, which is really about how do we create this model for higher levels of policy abstraction. And this abstraction from a networking perspective is not necessarily something new, as virtualization is not really new from a network perspective. We've been doing virtual networks in the wide area for some time. In fact, for many of our carrier customers, the most profitable business that they drive today are the IP virtual private networks that they manage as a managed service on behalf of their enterprise customers. So think of that as the first example of an overlay where essentially the user would define the network and security policy, and the carrier would essentially manage that private network on behalf of the users. This allows us to, as Jonathan was talking about, federate different domains, be they public cloud, private cloud on-premise with an OpenStack virtual private cloud implementation, or in a hosted environment that may be in a public environment. And we can essentially have the promise of application portability where we could move, let's say, a set of containers that belong to a virtual network across to a different location completely and still respect the policy that was defined for that set of containers. So from a networking perspective, IP has always held up as the ultimate abstraction between the application layer and the physical media below. And that in the early days of IP, you had a number of proprietary protocols like SNA and AppleTalk and DECnet. And the problem was, how do you federate each of those local area network environments into one common abstraction? We see a similar thing, obviously, in these early days of cloud. And this is relevant to a number of diverse market segments. In the case of OpenStack, we're seeing that the pace of going from evaluation to production is very quick. In many cases, for this first segment, the emerging segment, we see that they often move from POC trials to an actual deployment in 4 to 5 months. And there's this whole notion of sort of rapid prototyping, as many of the agile software development folks are embracing, where you fail fast, you move quickly, you anticipate failure. You don't test it for 12 months and make sure that it's rock solid, but you essentially keep your failure domains very small so that if there is a failure, you don't impact your entire system. You don't bring the entire thing down. That distributed systems model is essentially the way that the internet was able to grow to 4 billion IP addresses in a short period of time. If you take out one router in the internet, you don't bring the whole system down. And in the early days of a controller-based model, that was the problem. You created a single point of failure where you brought the whole thing down. A lot of the challenges in adopting these types of new models are not technical. And if you think of the stakeholders in adopting a new model of cloud, there are often various stakeholders that have different goals and priorities. In the case of the application service developers, they want essentially a predictable sandboxed environment where they can have isolation for themselves as a tenant in the cloud, and they want to quickly, and they want a lot of flexibility in the types of tools that they use, and they want to move very quickly. The cloud administrator and the network administrator obviously has to make sure that this environment is secure, that they pass their compliance, that they essentially keep their costs down, and that they serve a number of different stakeholders. And then, of course, the end user, the customer's customer in this case, has very high expectations and essentially has more freedom to essentially go to a different environment if it doesn't meet their needs. So we see a lot of our enterprise customers building out virtual private clouds with Openstack. Because a lot of the challenge that they see is in the enterprise, a lot of the hotshot application developers are using the public cloud unbeknownst to the IT and cloud teams. So then the CIO comes to them and says, why am I paying you if my users are going and charging their credit card in the public cloud environment? So they want that experience, obviously, of a scale-out elastic cloud with a lot of services. They don't want, obviously, the overhead of filing a trouble ticket and waiting 4 weeks for that service to be enabled. When you're dealing with a brownfield environment where you have the challenge of moving from a legacy client-server virtualization environment to more of a cloud environment based on open source technologies, we also, again, have to federate because you can't throw away the old environment and just start fresh. So as Jonathan mentioned, from a networking perspective, we have to support open source and proprietary hypervisors. We're seeing a lot of demand as people bring on bare metal servers and container-based implementations. We cluster that, or we federate that in a single data center or across data centers, the same way that we federate virtual private networks across the wide area. But the use cases are quite distinct. If you have essentially a legacy application, you're not doing a lot of investment, but you still essentially need to expose that to, through a self-service portal to your users. You want a consistent architectural framework for that. And then, of course, the administrators need a lot more visibility. If you look at the way that big data is being used for a lot of the next-generation messaging platforms and web-scale services, they measure everything. Web clicks, the way that the users are, network flows, TCP connections, CPU utilization, memory utilization. A lot of those diagnostics are available in the framework of Openstack. On the network side, though, how do we make sure that we're able to correlate that new data, which is now much more real-time and granular, with the data that existed in the physical environment? So the ability to discover the topology of the switching architecture, as an example, pull in SNMP, NetFlow, IPFix data, and correlate that to essentially what's going on in the virtual router in a Linux kernel in a single host, so that you can essentially trace those network flows from the server through the top of rack switch, through the routers, and back to the other side. That level of visibility and the ability to troubleshoot an issue and understand, is it an application problem, is it a physical problem, is it a problem with the virtual overlay, is it a user error, obviously is key to making this type of transition. A lot of customers will say, you cannot compromise as you move to a new environment. So the next few slides really just some of the examples where people really are using Openstack as a next generation environment for service delivery. This is an example from a European customer who very quickly, literally within 4 months, went from a trial to a production public cloud environment using OpenContrail in this case for the network service and using Ceph distributed storage to make distributed storage services available. The monitoring data that they exposed to their end users was very granular. So through their user portal, they exposed all of the information that essentially is available through the API servers in OpenStack and in the Contrail implementation. We also have seen a lot of the SaaS providers move, again, very quickly. In this case, a virtual private cloud for a security SaaS company who, once again, they built their virtual private cloud using OpenStack to essentially enable their application developers to move much more quickly in building out their SaaS application. If you look at the types of services that they expose directly to their application teams, not only compute, storage, and networking, but identity services, big data monitoring services, a lot of the user behavior and analytics. In this particular case, this was an example where the first use case was Hadoop on bare metal servers with essentially an OpenStack front end on KVM hypervisors. So that mixed environment we're seeing a lot of. Here's another example where We're seeing a lot of tier 1 carriers using things like heat templates, which heat is essentially the orchestration project within Openstack, where we can essentially define a human-readable YAML file, a template for service delivery and configuration. In this particular case, in the 4G mobile packet core of tier 1 carriers, there's a lot of change. And they have a big problem, which is often considered a cloud problem, which is you have a huge spike in user demand, and how do you make sure that you don't run out of capacity? So that ability to elastically scale, in this case, the control function in a mobile packet core, the call signaling, the steering functions, a lot of that infrastructure for the control plane of the mobility networks is being moved to an OpenStack environment as the infrastructure. And in this case, the virtual network functions of the mobile packet core control function are essentially running on that infrastructure. The policies that are being defined are obviously variable. They do variable rate plans for their mobile users. They have a lot of spikes in the mobility traffic. And this is a pretty complex environment. So they won't be the first ones to roll out on an OpenStack environment. But for sure, this is the framework that they're using because it breaks them out of vendor lock-in and gives their engineering teams a platform to innovate quickly in a vendor-agnostic framework that is open source, and there's a lot of transparency in how that's being developed. Here's another example we had done at the OpenStack Summit in Vancouver a couple of weeks ago. We've been working with NTT on essentially a software-defined wide area branch access scenario, sometimes known as VCPE, where they have a cloud controller based on OpenStack and OpenContrail, and they're using that to essentially deliver secure DTLS, SSL encrypted tunnels to a remote access device, in this case a very low-cost CPE device that is in an enterprise branch office. And a lot of the virtualized services then run either in a data center or in a regional office or in a server in the branch itself. So the portability of those network services, in many cases firewall services, IPS, denial of service services, as well as load balancing and caching type services are being delivered through that cloud controller model, and a service catalog that is available to their end users. So this makes, obviously, it gives the administrator a logically centralized point of administration, but it serves a very distributed model of end users where they're able to essentially just plug in the device, it calls home, it sucks down its configuration, all the credentials are established through a zero-touch provisioning model, and they're ready to go without a truck roll. So that's a huge change for essentially what is a $6 to $8 billion business today that is very manual, device-centric, involves a lot of manual configuration and a lot of costly truck rolls. So those are just some examples, and I'm about to wrap up here. This model of open source and open software and essentially open networking, in the case of a lot of the software-defined activities that have been going on, is not only a technology change, it's really changing sort of the architectural patterns that we're seeing in a converged hardware, software, and services model. We're able to automate, in the case of services like WhatsApp, which just got acquired by Facebook for $19 billion. They serve 450 million users, and that team is 39 engineers. And they've built a very highly distributed messaging system on WhatsApp where essentially their users don't ever enter a user and password. Essentially, their mobile device authenticates them into the server, and they can essentially process, in what they've tested, 2 billion concurrent connections per server. Highly distributed architecture that essentially is massively scalable. In that case, they've used a customized implementation of XMPP, which is the same messaging system that we use in OpenContrail, which allows us to essentially deliver in a very lightweight way very distributed services in a very distributed architecture. So that's what I had. I think that points to some of the innovation that we're seeing, not only in Silicon Valley and in OpenStack, but these models where you have this converged messaging, commerce, communication environment is obviously one of the trends around the future of cloud computing. So thanks for your time.